Welcome to Coach Eichner's Math. Today we will be talking about Pythagorean theorem. When two of three sides of a right triangle are known, the third can be found using Pythagorean's theorem. Pythagorean's theorem, the square of the hypotenuse is equal to the sum of the squares of the legs. So as we're looking at it, the hypotenuse squared equals the leg squared plus the leg squared. So our hypotenuse is always the longest side, and it is always across from our 90-degree angle. Our two legs are going to meet at our 90-degree angle, and we have a tendency to call our legs A, B, and our hypotenuse C. Pythagorean's theorem is often called or often referred to as A squared plus B squared equals C squared. So let's go ahead and put that to use. Looking at example 1. We want to find the value of x. We know AB, and we are looking for our hypotenuse C. So A squared plus B squared equals C squared, or 3 squared plus 7 squared equals C squared. 9 plus 49 equals C squared, which in this case is 58 equals C squared. We're going to take the square root of both sides to undo my square. And as we take square roots, the square root of 58, I do not know the answer to that off the top of my head. So I'm going to take and I'm going to separate it out. I'm going to say 58 is 2 times 29. Well, right there, I've got two prime numbers. There's nothing else I can do to it. So I'm going to go ahead and just leave my answer and say C equals the square root of 58. Because the square and the square root cancel every time I have them. So, looking down below. Example number 2. We've got A and B. Our hypotenuse is always across from our 90-degree angle. So C squared equals A squared plus B squared. Now in this case, C squared is 6 radical 2. So we have to be careful and make sure we square the whole thing. 6 squared plus B squared. So 6 radical 2 is just 6 radical 2 times 6 radical 2. Because it is squared, equals 36 plus b squared. 6 times 6 is 36. Radical 2 times radical 2 would be 2, equals 36 plus b squared. So 72 equals 36 plus b squared. Take away 36 from both sides, 36 equals b squared. Take the square root, and just like we said before, the square and the square root cancel, so I'm going to say b equals some number. It's going to be the square root of 36. So let's see if we can break up 36 at all. 36 is 2 and 18. 18 will break down into 2 and 9. 9 will break down into 3 times 3. Now I've got prime numbers. So our trick here is to take our prime numbers and recognize that 2 and 2 go together. That's the same as saying the square root of 2 squared. So I can write a 2 outside my radical. 3 and 3 go together. It's the same as saying the square root of 3 squared. So they cancel each other out. We can write down 3. In this case, 6 would equal b. I'm guessing a lot of you already knew the square root of 36 was 6. I say we find that pretty easy. So looking on, let's look at example number 3. As we're looking at example number 3, the first thing I notice is there is no right triangle, but we must use these rules because obviously we're talking about Pythagorean's theorem. So, take a second to see if you can find my triangle. All right, looking at it, I hope you drew a line right there, perpendicular to the base. Because this is corresponding angles, they're perpendicular to each other. They're corresponding angles and they're congruent to each other. It means that my two lines must be parallel, which by definition, I know this will be 8. This piece has to be 5. 11 and 5 give me 6 left. So, redrawing my triangle, 6 and 8, looking for x. X is again C. So, as we're going through this, x squared equals 8 squared plus 6 squared, or x squared equals 64 plus 36. x squared equals 100. Take the square root of both sides. Well, we know that 100 breaks up pretty fast. We'll say that the square and square root cancel. We'll say x equals the square root of 10 squared. Well, 10 times 10 is 100, so I haven't changed anything. All I've done is made it easier on myself to say x equals 10. Because we know that anytime we're doing this, the square and the square root cancel each other out. Okay, so that makes it real easy. We're just left with 10. Look at example number 4. Find the value of x. Notice the first thing I see is a bunch of congruence marks, which makes all 4 sides x. And this piece right here is going to be c. So I'm going to say x squared plus x squared equals 5 radical 2 squared, which is the same as saying 5 radical 2 times 5 radical 2. This would be 2x squared equals that. 5 times 5 is 25. Radical 2 times radical 2 is 2, because radical 2 squared is just 2, equals 2x squared. So right now I recognize that I've got a 2 on both sides, so I'm just going to divide by 2 to get rid of my 2's. And say x squared equals 25. Again, same situation, got to take the square root. I know right now, real easy, the square and the square root cancel. Right here, 25, I'm going to go ahead and split it up, and we know that 25 is just 5 times 5. I've got one pair. Okay, so the pair goes outside the square root sign, so I would say x equals 5. Nothing left to put inside the radical. Looking down below, example number 5. Find the length of the diagonal of a rectangle with a length of 8 and a width of 4. So I'm going to call this 4. I'm going to call this 8. I've got a diagonal C, and I would have the rest of my rectangle right here, which I don't really care about. I only care about half of it right now because we're talking about the triangle created by the diagonal. So it doesn't matter which one you call A, which one you call B. We're going to say a squared plus b squared equals c squared, or 16 plus 64 equals c squared. Excuse me. So as we're looking at this, 16 plus 64 would give me 80 equals c squared. Take the square root of both sides. They would just cancel over here. Unfortunately, they don't just cancel for 80 as well. We're going to say c equals some number. So I'm going to go ahead and come up top here, and we're going to talk about 80 and split it up. 80 splits up, and it's up to you to determine how you want to split up 80. If you see right now that 80 is 4 times 20, that works. 4 breaks up into 2 and 2. Well, 20 just breaks up into 4 times 5. Well, 4 is just 2 times 2. So right now, looking at it, I've got a pair of 2's I'm going to write down outside my radical. I've got a second pair of 2's I will write down outside my radical. Notice I'm multiplying. And I've got a lonely 5 left that will have to stay inside the radical. So 2 times 2 is 4, radical 5, which would be your answer for example number 5. Flipping the page, let's look on at example number 6. Find the length of the diagonal of a square with a perimeter of 24. Well, the first issue I have is I have a square, and because I have a square, I know all 4 sides are congruent, and I know I have 4 right angles, which means as I create my diagonal C, I know A and B are going to be congruent to each other. Now the question is, what are A and B? They tell me the perimeter is 24, so I take 24 and I divide by 4 the number of sides. Each side must be 6. So I'd say 6 squared plus 6 squared equals c squared, or 36 plus 36 equals c squared. So 72 equals c squared. Take the square root. Square and square root cancel. C equals some number. So we got to break down 72. So when I look at 72, I say that'd be 2 times 36, which if you ever get in trouble, that's the first place I start is by figuring out if it goes into 2. 2 times 18, well, that's 2 times 9. 9 is 3 times 3. So as I'm looking at it, I'm looking for my pairs. I'm going to say I have a pair of 2's right here. I'm going to write them down outside my radical. I have a pair of 3's right here, so I'm going to multiply those things together outside my radical. Now notice I have a lonely 2 left. That 2 must stay underneath the radical. So 2 times 3 is 6. Square roots of 2 equals C. And that would be your answer for example number 6. Looking down below, example number 7. As we look at this example, it's kind of like the example earlier where we had a triangle attached to a quadrilateral. I know that this inside piece is 10, so this must be 10 right here. But they don't ask for the piece inside, they ask for the whole thing. So I've got to use my triangle. I don't know A, I know B is 8 and C is 10. So let's go ahead and say A squared plus 8 squared equals 10 squared, or A squared plus 64 equals 100. A squared is going to equal 36. We're going to take the radical of both sides, and we've already broke down 36, so I should already know that A equals 6. Now, not done with the problem. A does equal 6, but A is just this one piece right here, so I have to say that I'm going to add 6 to that 10 to find the length, and I'm going to have to add 6 to that 10 again in order to find the entire distance across. So 6 plus 10 is 16, plus 6 is 22. X would be 22, and that would be my answer. Appreciate you watching, and I hope you have a great rest of your day.